Awesome. All right. Thanks everyone for joining us for today's webinar. Before we get started, I'm going to cover 2 quick housekeeping items, and then we'll move through to the agenda and introductions. So first, today's webinar is live, and it's also being recorded. So for anyone who registered but won't be able to attend, they will receive a link to the recording afterwards, and then you all will receive that link as well. And then the second quick reminder is that everyone is muted, but we would like to keep this interactive, and you'll hear kind of us have a conversation over the next 45 minutes. So if you do have any questions, please drop them in the questions panel, and we will answer them at the end. If we're not able to answer all of the questions, we will be happy to follow up. All right, with that out of the way, moving on to the agenda. Right, there's a little bit of a lag, that's okay. So with that out of the way, like I said, we're gonna spend the next 45 minutes having a conversation about all things APIs with a few of our experts here at Rhapsody. So first we'll touch on what APIs are without the jargon and in plain terms. We'll talk about policy and technology shifts you should know about, how you can leverage APIs to unlock new value for your organization, and last but not least, strategies to modernize with APIs and HL7. My name is Deb Daly, and I lead product marketing here at Rhapsody. My background is in the healthcare policy, go-to-market, and product strategy space. I will pass it over to Marshall to introduce himself.
I'm Marshall Peterson. So background, I spent about 15 years running quality assurance and software development teams at a medical device manufacturer. From there, I went over to one of the network aggregators, now a QHIN, and ran solutions and implementations for 5 years. And since then, I've been a principal technical product manager here at Rhapsody. Caitlin?
Yeah. Hi, everyone. I am Caitlin Formal. I am a solution consultant here at Rhapsody. I have been working in the interoperability space for the last decade. My experience spans doing client product implementations, solution architecting, sales engineering, proof of concept projects, and overall just making sure that our clients have interoperable solutions that meet their needs. Nice to meet you all. I think with that, we're going to jump into what APIs are. And I think sometimes we need to pull the skin off and not think of APIs in necessarily a technical term, because we interact with APIs on a daily basis. So we can start simple. An API is an application programming interface, and it's just a way that we can connect to different systems or services to be able to talk to each other in a predefined set of rules. So I like to think of them as a translator between different applications, and it makes it possible for all the tools that we interact with in our day-to-day lives. And so one example you see here is when we're working with e-commerce or shipping. I think we all probably do some different online ordering. Is I want to know when my package is on its way. There is not someone that's in the warehouse that is giving it a day-to-day update on exactly where my package is. They're actually calling FedEx or UPS or USPS's API to give you those updates that might then be embedded in an email in their application to give you those updates. And so no one, these different places that you order things from, they don't need to house all of that GPS data that's housed between the actual e-commerce or shipping organization. Another example that we probably encounter on a day-to-day basis is interacting with Google Maps. And so anytime you do a search, like even for a restaurant, to understand where that is, that restaurant is not housing their own location data, they're calling a Google Maps API. Or this example here, when I'm calling a car using Uber or Lyft, they're utilizing the Google Maps API to present that data into that readable form that you and I consume on a day-to-day basis. Also, I'm sure if any of you guys do online shopping, you've probably encountered some different machine learning APIs. And so anytime you see whether you are Spotify, your recommendations for the next songs, the next playlist that you should generate, Or you can probably see here for your shopping recommendations on Amazon or any application that you see, you can see here that I lose headphones a lot and then I have a 1-year-old. These machine learning APIs, they kind of learn our behavior and different applications can use them. Amazon actually hosts probably the most robust one that a lot of external companies use to say, hey, what's recommended to make your user experience seamless? If you searched for something before, what are we going to search for next? So, continuing on, when we think about APIs, like in a technical lens, I mentioned it before, it's essentially a contract between two different systems. And when we think about what we use in a day-to-day life, let's relate that back to healthcare. So instead of bulky file transfers or manual processes, APIs allow us to use lightweight standards like HTTP, REST APIs, JSON and XML that are both human readable. And this makes them both fast, flexible, and easy to read. When we think about them in a healthcare setting, it allows us to kind of pull the data that we need. And we've had, worked with healthcare data for a long time. Now, sometimes healthcare data can be really bulky. And so APIs allow us to make those transitions a lot more lightweight and just have the conversations that we need to do to get the data where we need to be in the right place at the right time. I think Marshall's going to talk a little bit more about how we use APIs in real life and how we can relate those back to our healthcare standards.
Yeah, for sure. Deb, can you go back one slide?
Absolutely.
So this is an example of an API use case in healthcare. Again, the APIs in simple terms is a way for one system to ask another system a question and receive an answer. In this case, trying to close care gaps, I need to know when John Doe or if John Doe had a colonoscopy. And so I can hit a custom API that you see here from one system that's called procedure history. Again, this is a custom API, so we're going to talk about standardization a little bit later. But this is a custom API that says, hey, do you have John Doe's list of procedures so I can look through them? The system answers and says, hey, here is a list of John Doe's procedures. The most widely used format at this point is data standard is JSON. So you get a JSON payload, is very easy to read. A human can read it as well with key value pairs. And it says, hey, here's a list of John's procedures. The application would then either display the list of procedures as is, or it would cycle through and look for the actual procedure that was in question, in this case, a colonoscopy. So that's kind of a general example of an API, but with healthcare, we can't talk about APIs without talking about FHIR. And what FHIR stands for Fast Healthcare Interoperability Resources. And it is the kind of a standard for exchanging healthcare information electronically. It is in no way a new standard. It's been around for quite some time. Adoption has been or was bumpy for quite a bit, but it is quickly gaining steam. Most of us have come across it at least a little bit. This webinar is not a deep dive into FHIR, although I would love it to be. But we're gonna stay a little bit high level, and I just want to give you, if you're new to FHIR, a couple paradigms to work in. One is to think of FHIR as just a series of blocks, and each one of those blocks describes a real-world concept in healthcare interoperability. So you have things like a patient resource that contains the patient demographics, or you have a condition resource that maps to a diagnosis, and things like encounters for patient visits or procedures for things like surgeries. For those coming from the HL7 world, you can see, and this isn't a one-to-one always, but just a way to start thinking about it if you're new to FHIR, is the different segments in the HL7 message will sometimes map to individual resources. So you can see how information in the PID segment, for instance, would be found in a patient resource. So things like first name, last name, date of birth, the address, things about the patient's demographics. For diagnosis, the DG1 segment, you would look at the conditions resource. That's where you would find that information. PV1 would be kind of like the encounter. And you can see that because FHIR is built up of these individual building blocks, these individual resources, it allows me to, instead of getting all of Marshall Peterson's or John Doe's clinical record, I can ask for specific things. So I can ask for, hey, I need John Doe's encounters for the last 6 months. Or do you have any conditions for John Doe with these ICD-10 codes? So you can start to target specific pieces of information. On the next slide, we're going to show an example of what the previous query would look like kind of in FHIR. So you can see that with standardization of FHIR, things start to look similar across systems. So in that last one, the last example, it was a custom API. That one was called procedure history. But in reality, in a different system, a different EHR, that custom API may be called something different. When you standardize with FHIR, those endpoints start to look very similar, if not identical, and the query parameters and the way that you call these different resources are standardized across all the systems. It becomes very easy to connect to each individual system or EHR because you're using the same query across all those systems. Again, the response coming back is standardized as well. So FHIR becomes very standardized and where things need to be. It's easy to read because it is that key value pair, and it becomes similar across systems. Now, it's not magic. It's not going to happen automatically. One of the misconceptions out there is that if you have a FHIR server and I have a FHIR server, that we're good to go and we're going to be able to communicate. But there's different release versions of FHIR. There's different what are called implementation guides, and we'll go over some of that a little later. Different profiles that are used that may need translation between the two different systems communicating, and that's where the integrations the integration engines come in really handy to be able to do those conversions when coming in and out of a FHIR system. So that's kind of an overview, high-level overview of FHIR and introduction. A way to get started into FHIR, the specification can seem very overwhelming. It's a very large, detailed specification, but it is a good standard. It is a very good specification, and it is based on patterns. And so one of the ways to get started is to start with a resource like the patient resource and just dig into it and learn the different parts of the standards, the cardinality rules, when things are required, when they're not, what that looks like. The different query parameters, how to use them. And as you learn one resource, it's very easy to move from resource to resource. One of the big mistakes people make, though, I think, is digging into too many resources at one time. Really dig in, start with a resource like patient and learn the patterns that are used throughout the FHIR standard. Next, we're going to talk a little bit about some of the pushes that are bringing APIs more into prominence when it comes to healthcare interoperability. And we'll turn that over to Deb.
Awesome, thanks Marshall. And Caitlin, that's a really helpful overview of APIs and FHIR and kind of connecting that back to our lives outside of healthcare and then how we use that for healthcare interop. So like Marshall said, we're going to cover 3 areas that are really driving the use of APIs and FHIR in healthcare. First being global regulatory momentum and the continuation there. Second being using these to enable agentic AI as that becomes more and more critical to our operations over time. And then last but not least, unlocking those high value use cases, which we'll spend quite a bit of time on in the back half of the webinar. So starting with that regulatory piece, regulatory and policy bodies have been encouraging the use of FHIR and APIs for several years now, and we've continued to see that focus as well as incentives and requirements put around that in 2025. And I think the very simplified trend here is that regulators are moving to make FHIR and APIs table stakes for interoperability as opposed to a nice to have. I'm going to highlight 2 particular examples of this in the United States, and then I do want to touch on a couple of examples outside of the States as well. So starting with TEFCA. TEFCA is a federally backed framework in the US created in 2023 that was designed to create a single network of networks that are referred to as QHINs commonly for nationwide health information exchange. And in 2025, notably, TEFCA will expand to cover data beyond the initial treatment use cases and cover across payment, operations, public health, and benefits determination use cases as well with FHIR-based queries. And what that means for organizations that need to exchange data nationally or participate in the QHIN for any reason is that you'll really need to have those FHIR APIs in place. And over time, this will become not just a compliance requirement, but it will become sort of the main highway for data exchange across all of those use cases in the US. And similarly, over the summer, the CMS Aligned Network Initiative was stood up, so in around July 2025. It is a health data exchange framework where organizations can voluntarily commit to meet CMS's blueprint for modern, patient-centered, and real-time data sharing. And that blueprint includes FHIR APIs, bulk data exports, real-time event notifications, consent tracking, and modern identity verification. So I think the best way to think about that initiative is that CMS isn't trying to build all of the tech itself. Instead, it's setting up shared tools and a framework and then asking the private sector to build on top of that with the goal of having EHRs, HIEs, payers, digital health tools, all using the same basic standards so that everything is interoperable by default. And like I said, that type of regulatory push isn't unique to the US, so we see these trends globally. Two I'll highlight quickly are in the United Kingdom, NHS England has been developing and adopting APIs for data exchange for years and requires use of APIs for specific use cases like transfers of care and Care Connect. And then in Australia, the National Digital Health Strategy is the nationwide plan for digital transformation with interoperability at its heart. And FHIR APIs serve as that foundation, specifically for initiatives like My Health Record, where they're establishing a single longitudinal care record for patients. So like I said, just a few examples, and this is happening globally. And if anyone has questions or wants to kind of dig into those policies more, the RAPSO team is more than happy to do that. So I'm going to hand it back to Marshall to talk about agentic AI.
Yeah, so everybody knows AI is the topic of the day. It feels like, but it is true. APIs will play an important part when it comes to agentic AI. AI is in a position. It is in a state that it can be used. There are guardrails that have to be put in place, and you have to know its limitations. But it's just going to grow in its ability to function and add value. So to define an agentic AI, so it's basically an AI system that it doesn't just provide answers. It actually can proactively take actions towards specific goals. So things like making decisions, scheduling tasks, or triggering workflows. What that allows, it's within guardrails, right? But it allows this agentic system to do things. And what the APIs will do is allow the agentic AI to take those actions. It'll be one of the tools that are used. So this diagram is a very high level diagram of an agentic system, but a workflow that could be used. They'll use protocols such as A2A, which is an agent-to-agent communication protocol. It'll also use MCP, which is Model Context Protocol, which allows an agent, allows a system to expose what are called tools, resources, and prompts to an agentic system. And one of those tools would be APIs. So a workflow that could fit into this is if you think there's a scheduling agent that has received a discharge summary, it's analyzed the discharge summary and has found that the patient needs to have a follow-up appointment in 2 weeks. At that point, that agent would use the scheduling APIs, make calls to those APIs to find out things like provider availability, insurance constraints, and it would then use those APIs to schedule the actual appointment. Once the appointment was scheduled, you could see where it would then use a communication API, something Twilio would be like an example that it would use to then send text messages and emails notifications to the patient that it's been scheduled. So the main thing to remember with APIs and agentic AI is that APIs will help enable agentic AI to do things, to access information or to trigger workflows. Turn it over to Caitlin.
Yeah, we'll dig into some of those use cases that are directly applicable today and how they can kind of drive value.
Yeah, I think, diving into those use cases, we want to just kind of emphasize why APIs are valuable to use versus some of our standard ways of thinking about healthcare data like HL7. So I think we all know that HL7 is really rigid and sometimes requires an army on both sides to get something like a VPN funnel stood up. And I think that we have we've all created HL7 interfaces before where we've been given a specification, we receive sample data, and it has nothing to do with the specification. And so it's a lot of modifications, a lot of customizations. Whereas APIs allow for that lightweight, rule-based way of exchanging data. And it uses some modern web technologies like REST and JSON that are easily consumable for most developers. I think also most importantly is that, being able to simplify the different authentication methods when we are exchanging data, and for things like when we're changing the data, instead of doing the VPN tunnel, we can do OAuth 2, or we can do certificate-based TLS exchange, and these are all ways that our tools can very easily support data exchange. And so, HL7 has this, I think there was actually a question in the chat, like when would you use HL7 versus API-based functionality? And I think with, HL7, it's great. I don't think it's going away. It's a way to transact data, especially when both systems need to be able to house all the data. So if I need to get all of my ADT data into a lab system to make sure that the demographics are in sync with both systems, I need to make sure that's an event-driven solution. But if I'm trying to query for a specific use case to say, hey, how many, what is the lab result for this particular patient, or how many patients have this particular diagnosis, this is when the FHIR and APIs give you a lot more leverage and a lot more tools. So we're going to hop into some specific use cases where, you can probably just, as we talk through them, understand why APIs are going to add value. Hand it over to Marshall.
Yeah, so another hot topic right now is prior authorization as regulatory requirements push forward. Deb, can you go to the next slide, please?
It's loading. Give it a minute.
Okay, no worries. So prior auth right now is a pretty manual process. It can be painful for the providers, the staff, the payer, and the patient as well. There's a lot of back and forth when the clinician first orders treatment. The prior auth process starts. It's handled through phone, fax, anything that you can imagine. Basically, seeing if it's required. Once that comes back, yes, it's required. There's documents that are required that have to be pushed. Sometimes those are not enough, and so more documents have to be exchanged. Sometimes the procedure is done. This has probably happened to a few of us in the webinar, myself included, where you thought it was prior authorization was done, and it is post-procedure denial, to where it wasn't ever done. And so at that point, someone is responsible for it. The insurer is not going to pay for it. And so that becomes a pain point of stress for the patient, but then the provider also has to fight. So you can see where prior auth is a very high value use case. What has come about is everyone is moving towards the FHIR Da Vinci implementation guide for prior auth. And what a FHIR implementation guide, you also hear the term FHIR IG a lot. It's basically a guide, a standard that extends the base FHIR standard. So you'll have an implementation guide, for instance, for prior auth. You have ones for oncology, There's a FHIR for genomics. And the DaVinci covers automating the prior auth process using FHIR. We won't go into a deep dive, but there's basically three parts of the process. One is what's called CRD. That's the coverage requirements discovery. And this is where during the flow of provider initiating, it basically pings the payer's system through an API. Is prior authorization required, and if so, what's required? The next part is what's called DTR. It's documentation templates and coverage rules. This is where the payer system sends back to the EHR, here's what's required, and here's how you give us that information. And the third one is called PAS, or the prior authorization support. And this is a bundle of FHIR resources that's specified in the standard that can be sent back to the payer to fulfill the prior authorization request. That does get transferred or translated over to X12. And so in each one of these processes, there's translation that has to occur between the systems, but it's done via APIs. As important as prior authorization is, what I'd really like this to show is the pattern of taking a manual process and automating it through APIs. Because internally in our own workflows, there are things that we can automate via APIs. Some of our customers have a huge interest in automating some of the reporting that their teams are having to do manually. And you can do that by setting up an API and allowing through authentication, the correct organizations to come in and hit the API and retrieve the reports without someone having to manually go do the query, put it into a spreadsheet, and then send it in a secure manner. So you can see where this pattern of automating manual processes is important from an API perspective. Caitlin's going to talk now about some things, especially bulk FHIR, which is pretty exciting.
Yeah, no, thanks, Marshall. No, when we think about different utilization of APIs, some of that, use cases come up a lot more prevalently lately is how do I handle large volumes of data? And so if you're thinking about handling HL7, that's going to be a lot of transactions. Or even if, we're thinking about organizations like population health or research institutions that we really need a large volume of data. I don't want to be sending a million different API calls to get the data that we need. And that's where bulk FHIR can come into play. And so when we think about, different hospitals that may be generating like quarterly files, or like health departments might be collecting these like weekly spreadsheets, or wait for like secure file transfers. A lot of this can be solved when we're actually talking about doing different bulk FHIR queries. And so instead of involving multiple teams, we can actually solve this by some bulk queries. So instead of having multiple teams involved, in having slow processes, we can automate a lot of this using bulk FHIR, and that way we're actually getting the data that we need in a timely manner, instead of possibly needing outdated data because the spreadsheet was 2 weeks old when we were doing the query. So like with bulk FHIR APIs, bulk FHIR APIs are designed for organizations that need that large scale access to health data. And so we can essentially query for the data that we need using a bulk FHIR query. It's almost like sometimes we're almost sending a spreadsheet. What are all the patients that I need? Or what are all the patients with this diagnosis? We kick off that job within an external FHIR server, and the FHIR server runs that job. And so instead of inundating that FHIR system with multiple APIs, we're kicking that off, and then we can check the status of it to say, hey, when is this job going to be done? And it reports back with us to a file, with a file of all the patients that we need. And so this can be really efficient for organizations that aren't necessarily looking for real-time data, but not necessarily like, I need this interaction in real time. They're looking for a bulk patient information, doing additional analysis. This also kind of relates back to what Marshall was talking about with the different AI use cases before. It's as different applications are being developed where we need a lot of data, bulk FHIR APIs are going to become a lot more prevalent because we can source that data that we need, whether it's de-identified or not, pull that back in, within a single query without having to over-inundate our different systems. So it gives us advantages like speed and scale, a lot of standardization. It also eliminates a lot of redundancy. So I think a lot of times when different organizations are trying to query the same systems with their different spreadsheets or they're doing manual processes, it's just duplicating work. And so bulk FHIR APIs allow us to automate a lot of those queries, get the data and streamline the data to the organizations that need it. That being said, if you're trying to implement different bulk FHIR processes, sometimes for organizations that don't have a distinct FHIR server in place, we might do something like called a FHIR facade, which I think Marshall's going to talk about next year.
Yeah, so with FHIR facade, it's not necessary to have a FHIR server in all circumstances. There's a way to get started and answer some of the regulatory needs with just using what's called a FHIR facade. And a FHIR facade is basically an API endpoint with a transformation layer that sits between the end user and your clinical data repository and other systems that you need to grab the data. For instance, you could use an API Guardian, which is our API gateway offering, and one of our integration engines. You could stand up a FHIR patient endpoint, secure that with authentication. The system that you've allowed to hit that endpoint could then call that API. The integration engine would go back, grab the data that is needed. Remember, it's not stored natively in FHIR because it's not a FHIR server. Grab that data, transform it into a valid FHIR resource, and then answer. And it's a way to basically answer some of the regulatory requirements, or if you're trying to work with certain applications that are already used to working with FHIR, it's a way to meet their needs without having an actual FHIR server. The FHIR server would be a database plus an API that is storing things natively in FHIR. There's times to use the FHIR server. There's times when a FHIR facade will answer the need, but it is a way to get started with FHIR, working with FHIR, answering requests for FHIR functionality and FHIR interoperability without actually having a FHIR server. Caitlin's going to talk about how to use our integration engines with APIs, because they're powerful tools for not only calling APIs but hosting APIs as well.
Yeah, no, I mean we're talking about all of these different use cases for using APIs, and I would like to highlight that our engines can do a lot of this completely out of the box. I can host a SOAP or a REST endpoint. I can connect to an external API, whether that be SOAP or REST. Even more importantly, I can do the authentication that's necessary through the engines to make sure that we're, exchanging data securely. I think a lot of times when we think about how we exchange, healthcare data, we use a lot of VPN tunnels. A lot of that can be eliminated just with functionality that's built into both of the engines. So that includes like the OAuth token exchanges or our built-in certificate and key managers to do like secure TLS, data exchange. Those are all, implemented in the engines. I think probably the features that I use most when I'm interacting with APIs within the engine is just being able to connect systems that you might have an API on one side, or you might have a more legacy system on the other. So maybe I'm connecting a flat file that I need to map into a JSON or XML payload, or HL7 into either of those payloads, or vice versa. Or I'm doing a database extract. And so the tools within the engine allow us to do those mappings really effectively, conserving any metadata that we need and still do that secure API exchange. we're always, enhancing the engines to do more FHIR capabilities. And so FHIR can be natively imported into both of the engines into different schemas. So you can use it in the mapper in Rhapsody, or with your X-Lights or with your templates within 4-point. And different FHIR XML and JSON conversions. So we understand that HL7 isn't going away, but I think we also want to emphasize that a lot of our clients are doing a lot with APIs, and they're doing that with our engines and our engines alone. There might be some use cases where the engine itself, where especially if we're exposing data to the public internet, where we might want to introduce something like our API Guardian that Marshall's going to talk about next, to make sure that we're, not exposing data to the public internet. So pass it up to Marshall for that.
Yeah, so when exposing any API to the outside world, you'll want an API gateway in front of it. And one of the things that we offer is our API Guardian, which is a fully functional API gateway. So it has the functionality of throttling, rate limiting, IP whitelisting, all of the monitoring and logging. There are some functionalities that we built in as well that to couple it with the engines. There is something that we call the engine connector that basically allows incoming and outgoing messages to be intercepted by the Guardian, passed off to the engine, and then put back into the API workflow. For instance, one of the use cases that's come up is sitting the gateway in front of like an EHR FHIR server, where the call comes into the Guardian, goes to the EHR, grabs the patient resource, that actually goes back to the Guardian, gets passed to the engine, where information can be added or removed. So things like social security number could be removed, insurance information could be added. It's formatted correctly, passed back to the Guardian, and sent as the response. It also so the Guardian can sit in front of any of our own products, but then also EHR APIs, FHIR servers. So you basically have a single point of ingress into your infrastructure, where it helps with logging, troubleshooting, making sure that who's entering and what they're accessing. So it's a pretty flexible gateway solution that can sit in front of your infrastructure, and especially the engines that can act as an API development platform, but then also host the APIs that have been created. So pretty powerful solution when you combine the two as far as a API platform.
Awesome, thanks, Marshall. And the one other thing I'll add there is just that, as with all of the other Rhapsody solutions, it's really important to us that we kind of meet our customers and clients where they are, and so making sure that we're offering, a variety of deployment methods and hosting options as kind of a place to start. Awesome. So we have a couple minutes left, and we're going to touch on a few questions. First, I'll point this to both Caitlin and Marshall. Can you explain why API Guardian would be needed if you're using either Rhapsody or CorePoint as a service, so cloud hosted?
Yeah, that's a good question. So it depends on what you're using the RAS or Rhapsody as a service or CorePoint as a service for. If you're using it for the HL7 connections, then you're already using something like a VPN. If you're using it to expose actual endpoints, then you'll want some kind of gateway to sit in front of those systems to secure those APIs. So basically, there's two at a very high level. There's three parts to the equation. There's the development of the API. That's the logic that you put into one of the engines to what's going to happen when that gets called. That's the web services side of it. So there's the development part. Then there's the hosting, which happens in the engine. And then there's the security side of it, where you want the gateway to actually handle all the throttling, the limiting, the authentication that's required. Part of APIs is the authentication process. And there's different workflows that can be used as far as OAuth 2.0, basic auth, and so the gateway allows you to use those different things as you're exposing the APIs versus traditionally with HL7, you're using something like a VPN for the security side of things.
Awesome, thanks, Marshall. Just looking to see if there are other questions in here. I believe you just answered this, but there was a question about whether Rhapsody has native OAuth 2 support. And here's a good question. What advice would you give to teams that are in the early stages of scaling with API adoption in terms of how to identify the best places to stand up APIs?
Yeah, that's a good question. So there's a couple of, one also is obviously going to be the ROI, right? It's which one is giving you the most bang for your buck. If you're just starting though, it would be best just just like with FHIR. If you're just starting with FHIR, it's best to start simple. I would start with a simple API to expose some kind of reporting, just to get kind of used to what it means to actually work with APIs or API best practices when you're developing an API of how it should work and function. So I would start with something simple. You might have that option depending upon which use cases is the most high profile or ROI. But I would definitely, I know that some of the people we've been talking to are trying to move from HL7v2. They're being pushed to also support APIs, and it is can very easily be overwhelming, like drinking from a fire hose. And so I would settle on a single use case and go all the way through that and make sure it's functioning, and then start to scale it from there. Again, the advantages of APIs are the patterns. And you've heard me say that a few times during this webinar, because that's the power of APIs. It's the power, to be honest, that's one of the power of FHIR, is that there's these patterns that you follow. And as you learn those patterns, it starts to become very easy to implement new systems and APIs.
Awesome, thanks, Marshall. We are just about at time, and so I want to flash up on the screen a QR code and then a link that will let you kind of contact our team directly. I know there was a few other questions that we won't have time to get to, but we will follow up with you all afterwards if we didn't answer your question for a more detailed kind of one-to-one answer. And then second, you can always reach out to us and our team. We are more than happy to have a conversation about all things API, FHIR, or API Guardian as well. So I'll leave this slide up here for a moment. And as always, thank you for joining us. We hope this was an educational and good use of your afternoon.
Thank you all for your time.